Redux. We need to take a look at what Redux is and what problem it's trying to solve. And we need to, this morning, also look at just a quick refresher on some of our basic immutable functions on arrays and objects, because Redux uses this idea of immutability to do its thing. So we're going to look through all of that, and then we're going to jump into the code and the syntax of adding Redux to our project. So without further ado, let's take a look at it. All right, so we're in Redux fundamentals, and the way that this week is going to pan out is we'll be in Redux fundamentals for today and tomorrow, and then we'll be in async Redux Wednesday and Thursday, and then we'll be into our sprint challenge Friday. So with today and tomorrow, we have to actually hit all of these objectives today, because we can't just teach Redux halfway and teach half of it today and half of it tomorrow. We need to teach a full Redux flow for our apps, and then so today we're going to do that in our lesson, and then today's project is a little bit simpler, and tomorrow we'll add a little bit more complexity, and we'll just go over more examples. So also this week, just a heads up to everybody, the lessons and the examples we'll go over this week in lecture time won't reflect exactly what the projects are going to be like, because with Redux, building a simple enough project for you to do in the afternoons is pretty tough. And if we were to try and build an example in the lecture that was kind of like hand in hand with the project, it would basically be giving you the code for the project. So this week I want you to focus on taking the principles that we're learning in class and applying them in different situations in your projects this week. So it is going to be a little bit tougher, and Redux by itself is already kind of a tough subject. So just I want you guys to be aware of that and gear up for this week, and be ready to really push yourselves kind of mentally, and there's going to be some disappointment and some frustration, so that is completely 100% expected when we jump into Redux. So use your resources that you have in TK. There's lots of links, different videos you can watch to get a different feel for these objectives. But yeah, just want to let you know that we're going to, the week is going to be a little bit tougher, and that's okay. That's exactly what we expect at this point. So, okay, let's jump into it. First of all, we're going to talk about these specific functions here: object.assign, and then these three array methods: concat, map, and filter. And so let's open up a replit to go over these things. Okay, so we want to be in ES6 because that's what we are using for this. So the reason we want to talk about these particular methods are they are immutable methods in JavaScript, and Redux is based on the immutability principle. And so as you learn these and you familiarize yourself with immutability, it's only going to help you in all of your code, not just React, not just Redux, but all of your JavaScript code and other languages as you move on to learn those. So the idea of immutability isn't a new programming thing. It wasn't introduced with Redux. It's not a React-specific principle. It is a little bit weird and clunky in JavaScript, though. So let's go over these quick examples and see if we can figure out, work our way through it in JavaScript. So I've got a couple, let's see, a couple things here. So let's look at these. These are primitive values in JavaScript. We've got string, booleans, and numbers. Because these are normal primitive types, we can do something like this. And when we console log this out, we expect to see that new num is 43, right? But what's going to happen if we do new num equals 33, and then console log both of these? So what do you think is going to console log for number down here? Okay, got some answers. Let's check it out. So as we run this, they both are being passed 43. They're both logging at this point 43. So kind of an interesting that they keep the same value even though we tried to change new num here. So this doesn't work with, this isn't the same when we're dealing with objects. And we need to learn about doing this with objects because let's see. Thanks, I was like, why is that happening? There we go. Okay, whew, I was trying to catch up with myself there. All right, so new num is changed to 33, and num stays the same. Okay, my mind was going crazy for a second. Thank you for catching that. So we can't do this same thing with objects, and we need to learn how to deal with this with objects, because in Redux we're going to have an immutable store. So we're going to set up a store that's going to be an object. Okay, so when we, unlike this example here, we can't just assign a new number and because these are primitive types and they're going to keep the reference to, they're passing values, not the reference. So new number here gets past the value of 43 and not the reference to num itself. And so we can change new num and we're not going to have any immutability issues, and num isn't going to be affected by this line of code. So that's not the same with objects. We have to be a little bit more careful with objects. We have to use some of these immutable methods when we're working with Redux and with the state or our store object. So our store object is going to be all the data that we need inside our application. So let's take a look at working with objects, which are reference types and not primitive types. Actually, let's keep this up here. Okay. So let's create an object. And we'll say, we'll call this person1. So we have person1 object. Then we're going to create person2. And we're going to set that equal to person1. Then, of course, if we console log this, and run it, we have the value here that was person1. But we're not just passing the value from person1 to person2. We're passing a reference. This is a reference type. We're passing a reference of this whole object to person2, a reference of this variable to person2. So now watch what happens. We're going to console log both of these. So now watch what happens when we do something like person2.name equals George. George, there we go. Okay, what is going to be logged for person1 and what is going to be logged for person2? Brian says George. Is that for person1, person2, or both? Ooh, good question, Patrick. We'll talk about that in just a second. So you guys are correct. Both are going to be logged as George. So let's take a look. Woo! Okay, so why did that work? We set a constant variable called person, and we gave it a value of an object with a name property and a string for that value. And then we set person2 equal to person1. So unlike up here, where we set new num equal to our old num, when this happened, new num did not receive a reference to this particular variable. All it did was receive the value 43. So doing this with a primitive type, like a string or a Boolean or a number, is basically the same as just typing in the value. So we're not passing a reference to this variable. Now with reference types like arrays and objects, when we do this, we're not simply passing the value to person2. So this is not what happens. Your browser is going to, the JavaScript engine is not going to create two variables with two different values. It's going to create one variable here with an object as the value. It's going to create a second variable called person2 that simply points to the value of this object. So this, in your computer memory right now, person 2 does not have the value of an object like this. It is pointing to the value of person 1. So when we change person 2, when we say person2.name is something different, it's changing this original object right here that's saved under the person1 object. So it's changing this value. And now both person1 and person2, which are referencing the same object in memory, have George as the value for the name property. Okay, perfect. Yep. So we'll move on from that. If you have other questions about that, you can reach out to me, take a look online. I was didn't know how this lesson was going to go when this example first didn't work out. It was like, I was really confused at that point. Thanks for pointing that out to me, guys. Okay, so let's move on. And let's talk about how we can accomplish what we're trying to accomplish here in a better way. So we'll say const person 3 is going to create a copy of this object and not just reference person 1. So the way we do that is through object.assign. So object.assign is going to take in 3 arguments. And who can help me out with what these 3 arguments are supposed to be? So let's get the first argument. Okay, so the source object to create. Yep, so remember, we're trying to create a new object rather than reference this old object here. So yep, we'll pass in an empty object. Perfect. So first argument is always going to be an empty object. You can extend objects here, so it's not always an empty object, but for what we're doing today and this week, within Redux, we're going to use empty objects. Okay, second is perfect. So the second should be the object you want to copy. Yes, this first one is the target object. So we're creating a brand new object. If we wanted to extend an object, we would put something different here. But since we're trying to create a new object and accomplish this without changing person 1, we're going to create an empty one here. So we want to copy person 1. And then what is our third argument going to be? Perfect, the new values. Yep, so we're going to say name is Ron. And then we're going to console.log. Let's remove this one for now. And run that, and there we go. So person 2 is a direct reference to this exact object. And if either person 1 or person 2 changes, both person 1 and person 2 will reflect the change of that object. Person 3, we're creating an entirely new object, and we're assigning the new value for name right here. So we're going to look at person 1, copy everything inside person1 into this new object, and then any values that we want to change happen in this third argument. The final way we can look at doing this is to simply use the spread operator. So we want to create a new object. We're going to spread in everything from person1. Then we're going to replace the name object, or the name value. So let's just comment those out. So both of these ways are accepted ways to accomplish this goal, where we're trying to change the name without without changing person1's values. Okay, any questions? Okay, perfect. All right, so we understand that this is the idea, this is the principle of immutability. And it's my personal preference to do things this way and avoid using references wherever possible. Finally, let's look at array methods. We need to understand our array methods. So let's see. If we have an array, and let's do map. If we want to use map to double every value inside an array, then we would map off of our array, and for every iteration it's going to receive a number, and we're going to return that number times 2. Now, the reason that we need to get used to map and filter and reduce is because these three and some others, these particular array methods are immutable methods. So we want to get really used to using these ES6 methods here. And what happens is the reason they are immutable is they all return a new array instead of a reference to our old array. So running this function will create a new array, and that will be the value for new doubled array. We'll say R. So if we console log our old array, and we console log our new doubled array, then we have 1, 2, 3, 4, 2, 4, 6, 8, 10. Let's look at filtering. So let's do const evens, and we'll do myArray.filter. This is the same thing here. We're just going to return any number that is an evens number off of myArray. So we look at num, and we use the modulus to see if it is even. We're going through this quick because this should be a just a refresher on these methods. If you feel like you need to study this more, please do so, because this is important stuff to know as we get into Redux. So there's our odds, there's our evens array, and you can see that after all of this, after running everything off of my array is still unchanged up here. So we have not changed our original array. And that's what makes these methods immutable. Okay, so let's do one last one. And I'm going to take this example from TK. So we're going to have an object from Ryan, and these are Ryan's scores, and this is his age. And we're going to run off of my object dot scores. We're going to look at his scores, and we're going to set it equal to, we're going to reduce them and add them all together. So if we console log my object, now we've reduced the scores here, but we don't want to do this because we're now changing our object, right? We have used my object dot scores, and we have changed the value of scores, where we've added them all together and created this. So a better way to do this would be to create a new object and use object.assign, pass in an empty object. We're going to copy my object. We're not going to change any values. Now we're going to change new object, and we'll console log both. And our original object has stayed the same. We have not mutated our original object. This would normally happen inside a function. So we're going to be writing pure functions that does all of this, that does this logic, this copying arrays, copying objects, and then returning values out of those pure functions. So we wouldn't normally do this kind of a thing outside of a function, because then we have a constant variable that's being changed. New object that's being changed right here. So this is something that will happen inside pure functions, and we'll see that kind of in the works today. Okay, any questions with immutability? Oh, cool, I was just going to drop that link. Awesome. Let's see, is there ever a reason to use object assign over the spread syntax or vice versa? What is the reply? Using object spread operator. Well, let's take a look for the whole class. Since one of the core tenets of Redux is to never mutate state, like we've been talking about, you'll often find yourself using object.assign to create copies of objects with new or updated values. An alternative approach to this is to use the object spread syntax added to JavaScript specification The advantage of using the object spread syntax becomes more apparent when you're composing complex objects. So it sounds like it's more preferable at this point to use spread syntax, which you'll see in our projects or today. So cool. So yeah, I will use spread syntax, and where is it? Here we go. I'm going to use spread syntax. If you see object.assign, you'll see this a lot in older repos and older code bases. The projects that we have this week may have object.assign in them, so it is important to understand this syntax. So my lessons will be here. Projects may be here this week, and the reason I'm okay keeping them kind of separate is you'll get to learn newer syntax, and you'll see when you get hired, a lot of your companies very easily could be using object.assign. Okay, let's take a quick break, and we'll come back and we'll look at, we'll jump into Redux. We'll see you guys. So we've talked about immutability and looked over the proper use of these different functions. We want to discuss now why do we have Redux, where did it come from, and what problem is it trying to solve? So let's just open up Redux. Oh, that's not what I want. Here are the docs for Redux. This is good to go through. We're not going to go through a lot of it in lecture, but this is a great resource. So this introduction especially is really good, just walking through each of these things, and then the basics. So these two tabs, Introduction and Basics, I would highly recommend going through at some point this week. The motivation is a good section to learn why Redux came about. And I'll give you kind of the short version, but basically JavaScript single-page applications have become increasingly complicated, and it's really hard as developers for us to control our state. And state is basically the data that we need for our application. So these front-end apps that we're making, these single-page applications, are increasing in their complexity, and it's harder and harder to manage our state because as you have lots of different components affecting the same piece of state, we get this that kind of happens. At some point, you no longer understand what happens in your app as you've lost control over the why, the when, why, and how of its state. And there's lots of reasons. There's a few reasons that could happen, but just for brevity's sake, just understand that this is a problem when you have big, complex applications. You lose control over the state or the data of your application. So Facebook decided that they wanted to try and tackle that problem and find a solution for it. And the Facebook team came up with something called Flux, which was basically just a way for them to say, this is how we're going to handle our state in our entire application. It was just a set of rules and a data flow that had to be adhered to everywhere inside their applications. Then they realized that they wanted this for other people, and Flux was a little bit too heavy for most React developers, and they wanted to create a library that followed the principles of Flux but wasn't so heavy and so involved. And so Redux was born out of that whole situation. So that's why we have Redux. Let's take a look at this page here to kind of get a visual at what happens. So without Redux, we have this kind of flow happening that we can already start to see in our React components. We've got a wrapping component that is taking care of state. And maybe down here we've got a component that has an input that also takes care of its own state. And this has an input that's taking care of it that isn't taking care of its own state. It's getting its state from this component up here. So a piece of state that lives up here is being passed down by props all the way down to this component down here. And when we want to update that piece of state, then we're sending events all the way up back up to our container, and we're changing the state up here. But that state also happens to live down here, so it's being displayed in both components. And as this model continues to grow, we just get in a big mess and spider web of managing our data and making sure that it's always in sync across our entire application. So this becomes very messy very quickly in a large application. So with Redux now, we remove the data from the data management from our components, and we put them into a store. And our store, our Redux store, is now one source of truth. One source of truth. Okay, we have a single source of truth for the data, for the state, for our entire application. So this makes handling our data, managing our state in our entire application a lot easier than just trying to handle it in each component tree that we are building. So this is just a good quick visual of why we bring in Redux and why we use Redux inside applications. Okay, so let's talk about how we bring in Redux and how we get it working inside our app. So let's jump to the docs. We're going to look at basics, and we're going to start to see a couple things that you're going to get very used to talking about and hearing about over the next week. So we've got actions. Oh, that's a horrible color. Come on, come on. We've got actions, reducers, and our store. And actions we're going to split up into actions and action creators. Okay, so get used to hearing these names: actions, action creators, reducers, and the store. Let's take a look at the flow of the basic Redux flow. And then we'll jump into the specifics on how how to put this together. So the data lifecycle in any Redux app follows these 4 states. We're going to dispatch an action. Okay, we will dispatch an action. Now don't worry, I know you don't understand this code yet, but you will. We're going to dispatch an action from our component. So some action from our component, like maybe we hit a button that adds a new item to a to-do list, or we push a button that increments the count, like into this afternoon's project. So some user action is going to dispatch a Redux action. Then a reducer function will get called and will update the state in our store. So an action gets dispatched, a reducer function gets called, and our store, don't worry about this one yet. This is just when we split out into multiple reducers. Then the Redux store will save the complete state tree returned by the reducer. So what this means is the Redux store will save the new state that we just built. So step 1, an action is dispatched, a reducer function is called, is invoked, and our state is updated through the Redux store. Our Redux store is updated and saved. Okay, so let's take a look at how this all happens. So we're going to import create store from Redux. Now, this is going to be important to realize real quick that this is not inside a React app. This is just all raw Redux right here. So we're just going to look at the flow, but we're not yet inside a React app. So we're going to import create store, and we're going to create a store of data. So we create a store of data right here, and we call it initial state. And we've got Fred, who's age 30. Okay, so now we're going to create a reducer function that, let's talk about what reducers are. So reducers are a representation of how our state and store changes within our Redux application in response to actions. So reducers manage changing our state. So a reducer is a pure function that takes in 2 arguments. So we're going to pass 2 arguments in. We're going to pass in state, and we're going to pass in an action. And that makes up a reducer function. Okay. Have we seen this syntax before? Have you guys seen this in anything you've done with JavaScript in this class? If you've seen it outside of this class, that's awesome. But inside this class, have we seen this right here? A little bit. Okay, so we'll talk about this real quick. This is a new JavaScript thing where we have a parameter that has a default value. So what this means is if this function gets called and we pass in, and we don't pass in state here, then state will be, or if we pass in like null, or if state is blank, then we are going to give it a default value of our initial state here. So it's not, we don't really need to delve too deep into this, but I just want you to understand that if this function gets called without something passed to state, that it's going to just receive this initial, this is going to be the default value of state inside this function. So let's take a look at this. When this first gets called, it's going to return an object, which is going to be our initial state. And this is going to be the state that we can get anywhere in our application. So it's this part right here, the store. It's this right here. Our store, or our state, for our entire application is, oh, get out of here, annotate, okay. Is what's being returned right here. So with this, we are setting up, and this part right down here, we are setting up this outside store with our data that we need for our application. So that's what this piece is going to be. We're going to take this user reducer function and pass it to this function that we imported. And that is going to create our store. See, I told you they were the same. Store, 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 store. Woo! Okay, cool. Let me erase that drawing now. So now, with these three steps, we have created the store for our application. It's going to store all our data, and anything that is going to update our store or update our data is going to have to go through this reducer here, which is a pure function. And you'll see why we talked about all those functions at the beginning of the lesson in just a second. So we're going to run this function, and we're going to console log our initial state. And Redux gives us this store object, gives us some handy dandy functions. So we're going to call store.getState, and it's going to retrieve the current condition of our state. So there we go. Initial state is now set up right here. And we console log that by running store.getState. Okay, so now we don't have to worry about this part because our React apps will, or Redux will do this under the hood in our React apps. But we need it here since we're not technically inside a React app. But basically, we're going to listen, we're going to subscribe to any changes that happen on the store object. So if this changes at all, if we change our store, this console log will fire off, and we will see in our console that we're making changes. Okay, so let's say that we're in our application, and oh hey, Redux, something has changed in our application. We need to look at actions, and we need to look at what changed and how did it change. So we're going to run a function called store.dispatch to make a change to our store. Remember when we were looking here at the data flow, the first thing that happens with our data flow, the thing that kicks off our data flow is dispatching an action. So let's go dispatch an action. Dispatch takes an object that will have two specific properties on it, type and payload. So here we have dispatch is going to take an action. And remember, an action is just an object. Let's write that down. Action is just an object with those two properties. So the properties are type and payload. Type. Payload. It's going to be something here. Okay, an action is just an object with type and payload. So let's say that we want to, let's change the name of our object up here in state. So the type of an object is a description of the change that took place. So we're going to describe what change we want to make to our store inside our type. So we're going to say change name. And this is the syntax you want to follow. We'll get into why we do this later. But for now, just know that this is the syntax we'll follow. So the type is going to describe our change. So we want to change our name. And then the payload is the data changing in our state. So we're going to change our name to George. We'll keep with the Weasley theme we've got going. So when we dispatch, when we run dispatch, we pass in this action object. Okay? We're passing in an action object when we dispatch. And actions have a type property which describe the change that's going to happen. And they have a payload, which is the new data that we want to update in our state. Now notice that right now, in our initial state, we've got a name property with a string, and we're not saying anything in this payload about, we're not doing this, right? Our payload is simply the data that is changing, not the property that's going to change and then the data. We simply just want the data that we're changing to. Because we're going to use this type to tell our reducer how to change our state. So let's look at that. When we run store.dispatch, that will trigger a call to the reducer. So under the hood, store.dispatch is going to take in an action. It's going to take in also the reducers that we have, and it's going to invoke our reducer, and it's going to pass in the current state, and it's going to pass in this action right here. So we're going to have this object. I'm going to copy that and put it above our reducer. So this is our action that we're trying to, or that we're passing to our reducer. So when we run store.dispatch, under the hood, it will trigger this reducer. It will invoke this reducer, and action will be this right here. So we want to take this object and we want to tell this reducer to update the name in our state with this action here. So we're going to use a switch statement, and we always default return state. So the default for the switch, default return for the switch statement is going to be the state. But if you look at our switch, you'll see that we're looking at the type of the action being passed in. So this is the connecting piece from how, when we run this right here, how it's going to update state.name with this payload. So anytime we dispatch an action with the type change name, we're going to change the name of our state object. So let's look at, for the case, change name. We're going to update our state that's coming in right here, and we're going to return our new state that we're creating. So this is where we get into immutability. We can't just say state.name equals action.payload. We need to copy. We'll do this in a couple steps. We will copy state to a new object, then update the name property. Then return the new object. So let's do it. We're going to put this all in the same return here. So we're going to copy the state to a new object. So we can do object.assign, or we can do the spread operator. Okay, we've copied our state to a new object. Then we're going to update the name property with our payload. Then we return the new object, which we're doing here. Okay, so let's look at the steps, and then we'll run this and see what happens. So our project gets built like this. We set our initial state with this object that says the name is Fred and his age is 30. We're going to create a store by passing our reducer to this create store function. So we're creating the store object by running this. And what this is going to do is it's going to set up our initial state through this default parameter here. So it's going to set up our state with this initial state, which we've seen right here. Then we're going to dispatch an action that says we want to change our name to George. By running dispatch, this will trigger a call to the reducer up here. So user reducer will get invoked, and it's now going to have an action passed to it. So we're going to look at the action type, and we're going to say if the action type is change name, then we're going to copy our state and update the name property to whatever we pass as the action payload. Then our store will see that it was updated, and we'll console log that our state changed, and we'll see our new state console logged here. So let's do it. We're going to run this. Drum roll. And there we go. We have our initial state, and then with the dispatch, when we ran dispatch, we saw that our state changed, and we updated our state to George. Okay, let's look at this here. Whew. All right, got a lot going on here. Default props. Yes, yep. That's a good way to look at it, Brian, for this, this part right here. State equals initial state. Switch statements, yay. Okay, so Michelle says, so the reducer is like set state, but it does not change the original state in the store. Yeah, reducer is exactly what set state does on the component level, or what, let me say that again. What set state does on the component level, reducers do that on the store level, on the Redux level. So yeah, that's actually a really good way to look at it. Okay, yes, subscribe is for an event listener for state, but we won't need to do this in our applications. So don't worry too much about this piece of code right here. Okay. Yeah, it looks like we're just kind of talking about switch. This would be the same as writing if action.type equals change name, run that, run some code, and then the default is your that way. So with a switch statement, we basically have a bunch of if-thens or if-elses. So here would be, I guess this is more appropriate here. If action.type equals change name, run this code. We'll look at another case in just a second. We'll say change age. So that would be then the continuation, else if action.type equals change age, then run some code there, and whatever we run inside here would be the code in there, and then this is just finishing your else statement. If nothing matches, just return the state as it is. Return the current state. Don't change anything, just return the current state. So good questions. Let's look at one more. Let's look at one more quick example for change age. Then we'll take another break and we'll put this all into a React app. So you guys build this out for me. How are we going to change the age of Fred, who's now George? Yeah, that's what we're going to do inside our reducer. Perfect. Let's plug that in. But what is age going to be? We need to change age. Where do we get age from? Yes, action.payload. Whoop, whoop. Okay, perfect. So now how do we trigger this reducer and pass in the correct action for it. Awesome, we're gonna dispatch an action. Dispatching an action under the hood will invoke our reducer. Okay, so how are we going to write up our action here? Remember, actions is just an object with type and a payload. So what is our action going to look like? Nice. Perfect. Well, let's just go up by 1. We'll say he had a birthday. So let's run this. And there we go. With our first dispatch, we changed the name to George. With our next dispatch, we changed the age to 31. Awesome. And you can see the type of the last action to run. Okay. Great job. This is I'll give you this to reference. It's a great way to see everything in the same file. It gets a little more complicated when we put this in a React app, because we're going to pull out each piece of this and put it into its own folder and file. So let's take a quick break. I believe there was one more question. No, these are this is a really good question. Could they have been changed at the same time instead of 1 by 1? Currently, no. Redux, until we get to Wednesday, Redux is completely 100% synchronous. It will run this line of code and it will pause until this has happened before it executes this line of code. So it's totally synchronous. These will not run at the same time. They will run the first one first and then the second one second. And then up earlier, I might just have a case of the Mondays, but did we ever try to pass events back to the state from child components in our previous assignments? Did we ever try to pass events back to state from child components? So if I'm understanding this question correctly, yes, we have done this when we pass a function down through props, and then we we invoke that function with an on click or something like that. So whenever we have the examples we've seen with inputs, where our state for inputs is managed in a parent component, then we pass a function down for handle change. And if I understand your question correctly, that would be a good instance where we've done that. Maybe I'm not understanding what you're asking though. So. Yeah, so that's exactly that's exactly what I'm talking about. So if we have an input here, and then up here in our container component we have state dot input text. Then we also have a handle changes function. Oh, let's see, handle changes, blah, blah, blah. So we pass handle changes down as props, and we pass in input text as props as well. Then we set the value for this input as input text, props.input text, right? And then on change, with a capital C, we pass in props dot handle change. Handle change, and that passes in the event, which invokes this up here, invokes the function up here with the event. So yes, we pass functions down the chain, we invoke them with an on change, and that invokes them back up here inside this component, and then we run set state with event.target.value. And that new state gets passed down, and the value gets updated. I'll make sure real quick that that is what you're talking about. Okay, good. Let's see, anything else? So essentially our flow for this is state is our store, yep. Then dispatch, payload, reducer, changes. Yeah, perfect. Awesome. But events are async. Are events async? No, events are not asynchronous. Okay. Oh, more questions. So with Redux, we can dispatch in the child components. Yes. So what we're going to do is, in just a minute, is we're going to have a file called reducers, or excuse me, called actions.js. And we're going to import those actions directly into where they're needed. So we're going to have action creators that are going to be imported into our individual components, and we'll dispatch actions from our individual components. So that's a really good question. Any component that needs to change the state can dispatch an action from inside it. We don't need to pass that down from component to component. How do we dispatch a payload with a value that needs a reference of the current state of the store? Great question. We have that. Oh, let me erase here. So we can do, stop annotating. We'll see that in a minute, but we could basically do this, or let's see, store.getState, which returns an object, right? .age plus. Oh, we can't do that. But our setup is going to be a little bit differently in a React app, so it'll be easier to show that happening when we plug this into a React app. So let's take our break, and then we'll see a really good example of that. But that's a fantastic question. So we'll make sure to cover that in just a minute. Okay, we'll see you guys back in 5 minutes. To your computer. post. All right, let's take a look at using Redux in a React app. Somewhere in one of these. Okay, perfect. So I've got a pretty simple application here that is basically displaying the number that I type into this input box. And I've got my index.js, which is holding the state for my component, for my app, for this component tree. And then it's has an update number function that is setting the state. And we are rendering our number component. So we look at our number component, it's got an input with the value of props.number, and then it's also displaying props.number down here. And then it calls update number when on each change. And then I used your guys' awesome trick that you taught me with nesting headers. Booyah. So pretty straightforward. We should feel very comfortable with this kind of architecture here. What we want to do is remove any state management out of this, out of our app function, or out of our app component here. And we want to move all of this functionality into Redux. P.S. This is a newer way that we can set up state where we're not inside a constructor. So I wanted to display this for you today, now that you have learned constructors and the point of constructors and running super. Unless you need to use constructor for something else, you can now start using just state like this. So you're welcome. Less typing for you. Okay, let's bring in Redux. So we need two different libraries. We're going to use Redux. We're going to add Redux and React Redux. It's important that we need both of these. Redux is just basically the library that handles that whole data flow that we saw here. Nope, here. So Redux handles all of this stuff. It creates the store object. It triggers reducers when an action gets dispatched. And what React Redux gives us is just the tie-in pieces to bring this into a React project. So to get this started, we're going to look at using with React. So install React Redux, and I was hoping it would give us a better look at starting up. That's okay. I will show you what we want to do. Oops. Okay. So in our project, we're going to import our create store. So remember here we have this happening. We need this from Redux. And then we also need to have some tie-in piece for React. So this tie-in piece comes from Redux, React Redux. And it's called provider. It is a component that is similar to browser router that we get from React Router, Tom. We're going to take this provider component, we're going to wrap our app with this provider component. And this gives us access to the store that we're going to create with create store. Okay, so we've wrapped our app with provider, and let's create our store. So let's look at how we created our store here. So our application data is represented, so we create our store, const store equals create store, and we pass in a reducer. But in our React application, we're not going to have our reducer here inside our component. So let's create a store. And we're going to run this function, but we need to pass it a reducer. You can see right here, expected the reducer to be a function. And we don't have a reducer here yet. So let's look at our reducer file. We've got a reducer file, and you can see that we have created our initial state with the number 42, and we're exporting this function called numbers reducer. So export function numbers reducer. So we can, we'll actually export default this. So let's import this reducer into our store here, into our file here. And we're going to pass that there. Okay, so nothing's changed yet, except we're not breaking. We don't have that error. But we do have a store available to us. And it's not, we haven't used this anywhere yet, but we have a store now available to us. If we console.log this, then we can see that we've got those functions: store.getState, store.dispatch, store.describe, store.replace reducer. We use 3 of those up here, right? Store.subscribe, store.dispatch, store.getState. So we have our store created, and we are going to pass this store to that provider component down here. So the wrapping component that's wrapping our app, we're going to pass a store prop down that's going to be the store of our application. And this, the store now, the data that is now going to be accessible by our app is reflected in this initial state object here. So if we had other things, if we had color blue, if we had sidebar open false, all of these things are representing the state that we need throughout our entire application. Right now we're just going to deal with a simple one called number. And now we've set up our Redux store. So the next thing, we talked about how our store can pass data to our components. We're going to get data from the store rather than from state. So let's look at this component. Let's take out this idea of state, and let's remove this update number function, because we're no longer managing state inside this component, which means we're not going to pass this number prop down, and we're not going to pass this update number function to our number anymore. So the big question is, where do we get that data from when we're inside our number component? We know we've got 42 here. How do we get that over here? Let's look at the Redux docs, and let's talk about this idea of presentational and container components. We've talked about this a little bit, but this really becomes important when we're looking at Redux. So the idea of presentational components and container components is going to be important to us because we need to know where our data is being passed to from our Redux store. So this is a little bit misleading here. We're not going to pass data to every single component like this. We're still going to have some components that will take in, so let's say we have this as a component that's going to get data from the store. We're going to set that data to the state of this component, and we're going to pass that data down as props to its component tree, like so. So we still have this idea of props, and we're passing props down. We're still going to be invoking functions and passing them back up, but we're not managing data here anymore. We're just pulling data and passing it on down the line. So this top component is what we call a container component. And then all of these lower components are presentational components. So let's read about what these are. A presentational component. I really like this table. So let's take a look at this. Presentational components versus container components. So what is the purpose of each? The purpose of a presentational component is how things look. It's got the markup and the styles. And we usually call these functional or dumb components as well. The purpose of container components is how things work. They do the data fetching, they do the state updates. These are also called class components or smart components. Are presentational components aware of Redux? No. Container components are aware of Redux in that they're the ones that are going to receive the data from Redux. And they're the ones that are going to dispatch actions to update the state. These components down here, they don't care about Redux. All they care about are the props they're getting from their container component up here. So to read data inside a presentational component, you need props. So you pass data down from props, and that's how presentational components read data. Container components subscribe to the Redux state. We don't have to do the subscribe part. I'll show you how we have a really cool function that does this part for us. So container components are going to subscribe to the Redux state. Presentational components are going to read data from their props. In order to change data, presentational components invoke callbacks from props. Container components dispatch Redux actions. Don't worry about this part right now because, actually, let's do worry about it. How are these written? We write presentational components by hand, and container components are usually generated by Redux. So this might sound confusing right off the bat, but what is a pattern that we know about for creating, on the fly, creating components? Dynamically creating components. No, not quite. Well, yeah, that is, okay, yes. Yes, you're both correct. We can map and dynamically create components. Well, that's another way to ask this. Can we, or what is a function that generates and returns a component for us? Yeah, HOC, woohoo! So we're going to learn about a higher order component that Redux gives us, that React Redux gives us to generate these container components. But we need to, by hand, we need to write the component that we pass to that HOC. So don't let this confuse you. We still need to write the component that we pass to the HOC. But in the end, technically, React Redux is generating this component based on what we pass to it. Okay, cool. All right. So down here, technically you could write container components by using the store.subscribe that we had in our replit. We don't advise you to do this because React Redux makes many performance optimizations that are hard to do by hand. For this reason, rather than write container components, we will generate them using the connect function provided by Redux, as you will see below. So this connect function is the important piece that we need to know inside our components. So let's go to our component, and we're going to import connect from React Redux. Then we are going to, we wrote this function here. We're going to pass this component into the connect function. And we're going to export what that returns. Must pass a component. So the reason this isn't working is this function is just returning this here, right? So that's what it's receiving there. So when we connect a component, we need to pass in a class component. And we want to do this because, as we saw here, this is going to be how things work. So this component that we're passing in is going to be our data manager. It's going to work with Redux state to get data to all of its children components. And so we would normally do that inside a class function or class component anyways. So we'll change that real quick. Still getting the same thing. Let me see what I'm doing wrong here. Oh, I know what I'm doing wrong. Okay. So connect is expecting to be invoked twice. And props is no longer defined. That's okay. We'll get up to that in a second. So connect is wanting to, it needs to be invoked 2 times. So when it gets invoked the first time, it's going to return a function. We're going to invoke that function with our class component. So what are we going to do with this first function invocation? This is where the magic happens. This is where we can pull data from our Redux store into our component. So we're going to pull in from our store. So if we look at Reducer, this is our store. We want to pull in number from the Redux store. So let's put that in here. Oh, number is not defined. Okay, I'm not going to teach this middle piece. What I'm going to show you guys is this first argument is going to be a function. So, oh yeah, and it shows you the first argument is a function right here. So we're going, and that's going to be a function that we define, and it's always, we always call it map state to props. So this map state to props function is going to, oh, let's write this with better syntax. So our map state to props function is going to take in state, which is this state here, our Redux state, and it's going to return an object. And then this object is going to do a couple things for us. First, it's going to grab state.number from right here. So this object is state that gets passed into our map state to props function. So this object gets passed in right here. So we have state.number available to us. We'll get back to the error in just a second. Actually, let's just do that. Let's just do that. Then we are going to take this function and pass it as the first argument to our connect. Okay, so we're getting this console log from this state object here. So when we pass this function into the connect HOC, the connect hawk, it's going to invoke it with state. We can see the state object in our console log. And then we're going to map the state to our props object for our component. So I'll say that again. We're going to map this state to the props object for our component. And that's done inside this return right here. So map state to props. We're passing that in. This is failing because props is not defined, because now that we're a class component, this needs to be this.props. And there we go. So what was this whole process that we followed? We built out our Redux store inside our reducer. We passed that reducer to create store inside our index.js. And then with our provider component, we passed the store to the provider. Then inside our number component, we are wrapping, or we are passing our number component and our map state to props function to the connect function from the library, React Redux library. So in effect, what this does is connect gets invoked when this function, or when this function mounts. This gets invoked, and the first time it's going to run this function, and it's going to pass this state to that function. So we have state.number available to us right here. Then we're going to map state.number to props.number, this.props.number. So this part right here becomes this.props.number. And that's why we're able to see that 42 displayed on our screen. Because we have taken our state.number, mapped it to our props. We've mapped our state to our props. And now our component has this.props.number available to it. So let's call this number on props. So this part in your map state to props, the value is what gets added to the props object. Or excuse me, the property gets added to the props object. The value comes from our state in our reducer. So what if we change this to 36? Then you can see our state is updated. Okay, so the last piece of this is our action dispatching. So we want to now change our state using this input to dispatch an action, update our state inside our reducer, which will in turn update this component here. The way we do that is we're going to build out an action creator inside our actions file here. Before we jump into that, I'll just see if there's anything going on. Lots of good discussions. HOCs. If you use React Router's DOM browser router and the provider, which would wrap which? That's a great question. In my weather app, I have it like this. Cool. Yep, wrap your provider and then your router inside that. The reason for this is a lot of times we want our router to know about the store. So the provider and the store wrap outside of our router so that we, sometimes you actually use the store inside your router. We'll look at this tomorrow, I believe, multiple reducers. There's a function called combine reducers, which we're going to pass into create store. Yep, good job. Okay, so this is the next step. These are going to be our action creators. And magic. It seems like magic. Tomorrow we'll look at everything under the hood to take away the magic of it. Okay, awesome. We'll just be few more minutes and we'll be finished up here. So in our actions folder, we are building action creators, not actions. The action creators are functions that create actions. Woohoo! So with that idea in mind, we're going to build a function and we'll export it called change number. And we're going to return an action. Create actions, class name. Returns an action. So an action we now have type and, which is going to be a string, and have a payload, which is going to be something. That payload, we're going to pass into this action creator a new number, and we're going to make that the payload for this action. So doing things this way, we won't actually do store.dispatch. The actual dispatching is going to happen under the hood. All we need to do is create the function or build the function that creates the action and returns the action. Then we're going to import this action creator into our number file. Let's see, where are we at? Out of components into actions, and we should be good. Okay, so we've imported this function into our number file. So we now have our action creator in here, but we need to connect it to Redux. We need to let Redux know that this file has this action creator. So we're going to go down to our connect because that's where everything happens. And the second argument we're going to pass in is this object. And then this object is going to take in any action creator that we're importing into this file. So we've imported change number. So we're going to pass in change number like that. And that's it. That will, importing it here and letting Redux know that it's inside here as an action creator means that we can invoke this anywhere inside our component and it will take care of all the rest. It will dispatch an action which will trigger this numbers reducer, which we will in just a second use to update our state. So let's go to our onChange. This again, change number is on our props object. So we have this.props.changeNumber. And we're going to invoke that. And we're going to pass in a number here. But we know that we don't want to create an infinite loop. So we're going to put this inside an anonymous function. And we're going to pass in our event.target.value right here. Where does event come from? Event comes from right there. All right. So let's go to our action file and let's just run a console.log in action. Let's see what number gets consoled as. So this console log is coming from right here. We're getting our state. Let's change our number. So I typed in 7, and you can see that our action creator was invoked. But watch this. We're going to go to our reducer. We're going to console log in reducer, and we're going to look at our action. So let's push 7 again. Oh, cool. So we're in our reducer, and we have an action passed to our reducer with a type and a payload. You'll notice that this is a string, so we want to take care of that because we're expecting a number. So let's take care of that right here. We're going to go parse int, turn this into a number, like that. So if we type in 7 again, now we've got our number. But we also need our type. So we need to describe the change that's happening. So we're going to say change number. Then we're going to take this type in our reducer. Oh, let's do 7. In our reducer, we now have the change number type. So we can set a new case in our switch statement for change number. So if this gets invoked with an action that has the type change number, we want to, in an immutable way, update our state. Oh, not equals. Action dot payload. Now, if I hit 7, it updated, and we have gone full circle in our Redux application. Not a number. So some cases you will need to solve for weird things like that happen. Pretty simple. If we're in our action, we can ask if this is a number, and if it's not, then set it to 0 or something. Or we can just keep everything a string. Not worry about numbers, since we want to keep it uncomplicated right now. All right, so let's look at the flow one more time. We've got pretty good flow of through our console logs. So we're going to console log current state. Okay, so we've got our current state. You can see that our reducer already ran 1 time. And it's the initial time to give our components this state. It returns the default state to set up our store. So our reducer already ran once. Our current state is the number is 86 with our current state, as we can see right here. When we type in 7, we're going to see the action run with 867 passed as the number. We're going to see our reducer run with this action passed to it. Change number is going to be the type. Payload is going to be 867. And then we're going to see current state updated with our new number there. So let's do that. Let's run 867. Our action ran, our reducer ran, and our current state was updated to 867. If I do it again, the same thing happens. And there we go. That is a simple look at the fundamentals of Redux. There's a lot of moving pieces, but the project today is pretty straightforward, pretty similar to this. I think that the project today doesn't make this an object. I think it just says 86. So if our current state is 86, we no longer have the number property here. So we no longer have state.number, right? We just have state is 86. So we just need to do that. And then in our reducer, we would just replace everything with action.payload. The state is not an object. There we go. So just a heads up on that. You'll have to think through that little change if we don't have an object as our state, if it's just simply a number. Okay. I messed something up, but I will fix it before I pass this sandbox to you guys. Any last questions before I let you loose? I like this article for connect and map state to props. Cool, looks like this is a good article. I'll take a look at this today. It's just taking state from the reducer and adding it to the props object on the number component. Yep. If we had multiple, I think we just have to change that. Okay. If we, by chance, had multiple things on here, another property, which was some gobbledygook, then if you don't need that in your number component, then don't add it to your props. So the props for this component only has number on props. It doesn't have this gobbledygook here. So good question. The connect is basically taking the properties we need from our state, from our store, and adding them to, mapping them to the props for that component. We only need the number. We only need state.number here. So that's the only one we map to our props. We don't need this other one, so we don't map it to our props. Essentially, map state to props makes the props that get passed down to our component come from the store. Yep. And what's cool is we could still pass down a prop here. We could say name equals I am a prop. And we could go to our number component. We could say h1 this dot props dot name. And we still have that passed down. So mapping state to props doesn't override any props that might be passed down from a parent component. All it does is grab any values we need from state and add it to our props object. I'll keep that example there just so we see that is a thing. Okay. We need prop types. Yes, prop types would be very good to add. Cool. Okay, awesome. Yes, I've been posting this. Let me save all the things. Post it here. You have the code sandbox. It's a little bit different than the project, but use the principles that you know in React and JavaScript to finish your project today. And I think we should be good. If there's no other questions, then go have lunch and let us know if you need help with anything. Go Redux. Yay for state management. Have a great day, guys.